Shakespeare was the name of our content management system. It only really ran in Internet Explorer. I was working as a reporter at a financial news outlet in South London, a couple of miles from where this mural now sits, and in 2010 we relaunched our website. One of the requirements of the new design was that we should be able to reshape the article pages and the home pages without the dev team needing to do a release. So a brilliant engineer named Kane Vong built an extension to Shakespeare that allowed us to reshape the world by editing what were essentially HTML templates. Naturally enough, it was called Globe, after the theatre that Shakespeare's company of actors built. Now, as someone who worked in the newsroom and also sort of understood what a div was, I was somehow the least unqualified person to use Globe. And so the company had no option but to put me in charge of producing one of our verticals. And for a while, it was pretty great. It allowed us to be more responsive to our readers. It meant that we could do things that would previously have taken weeks of meetings. During the week, we could have a steady stream of breaking news like this, and then at the weekend, we could showcase our long reads and our features. The traffic numbers were going in the right direction, everyone was happy. But before long, our reach began to exceed our grasp. We wanted to do more interactive and rich things on the web. And all I knew about doing interactive stuff on the web was that you did it with Flash, which was very much a part of internet culture at the time and used to make things like this. But something terrible had happened. Flash had been murdered by the tyrant Steve Jobs. Rest in peace. And so to cut a long story short, I started researching alternatives, and that's how I found myself writing a language called JavaScript into a text box in a content management system that only really worked in Internet Explorer. I don't think we even had monospace fonts, much less syntax highlighting or linting or anything like that. And the results were entirely predictable. I broke things badly and often. What the dev team should have done was sanitize my markup, stripped out my script tags, but instead, and I'll forever be grateful for this, my friend Pete Lewis came to me and said, "Rich, I'm probably going to regret telling you this, but there's this thing that we use to write better JavaScript. It's called jQuery." And in that moment, my life changed. I went to jQuery.com, and my mind exploded into 1,000 pieces. All of a sudden, all of the things, the pie-in-the-sky ideas that we'd wanted to do were not just possible, they were within reach. I fell in love with jQuery, and the reason that I fell in love with it were these 4 words: write less, do more. My name's Rich Harris. I'm a graphics editor at the New York Times, and this talk is called The Return of Write Less, Do More. Part 1, write less. So there aren't many rules when it comes to writing prose, but this is one of the ones that pretty much everyone agrees on. Wherever possible, you should strive to omit all the various repetitive, redundant, or needless parts of a piece of writing and only keep words that convey useful information. Or in other words, omit needless words. This is one of the rules from a very famous book called The Elements of Style, otherwise known as Strunk and White after its authors. And it continues thusly: vigorous writing is concise. A sentence should contain no unnecessary words, a paragraph no unnecessary sentences, for the same reason that a drawing should not have no unnecessary lines, and a machine no unnecessary parts. This requires not that the writer make all his sentences short, or that he avoid all detail and treat his subjects only in outline, but that every word tell. And this isn't just about respecting your reader's time, it's about writing things that are more correct. Flabby prose creates space for bullshit. The more words that you have, the more you're able to paper over all of the logical cracks that would otherwise leap out at you. And having produced some short, concise writing, it's much easier for your reader to understand you. Now, I've been working for most of my career at the intersection between journalism and software development, and I have come to believe that writing software has more in common with writing prose than it does with engineering. Engineering is important. That's where we tell what the computer to do. But less important than the what is the why, and that's what code is about. As Martin Fowler says, any fool can write code that a computer can understand. Good programmers write code that humans can understand. I would even go so far as to say that if you want to become a better programmer, a good way to do it is to practice writing prose. It'll exercise a lot of the same parts of your brain, but it'll get you into the habit of evaluating the result from the perspective of a hypothetical reader. Nowhere are the parallels between code and prose more salient than when we're talking about size. If you assume a linear relationship between the size of a code base and the number of bugs in it, then that alone is a good reason to try and minimize the amount of code that you write. But it turns out that the relationship is not linear. It's quadratic. According to Steve McConnell, who compiled some data from real-world studies, a 10,000-line code base will have more than 10 times the number of bugs of a 1,000-line code base. It's really important to try and stay below that inflection point. 2 studies cited in the Mythical Man Month determined that the effort of maintaining a code base increases quadratically with a number of instructions. Now, one way I think to interpret that is that if you can do your code in a more declarative fashion, in other words, eliminating the instructions in favor of describing relationships between the different parts of a system, you'll decrease the surface area for bugs. And a little later on, I'll show you what I mean by that. You might think that this is something that only applies to a particular language, that 1,000 lines of C and 1,000 lines of Ruby and 1,000 lines of JavaScript would have different error rates. But it turns out that's not true. According to Les Hatton in his paper, Programming Languages and Safety-Related Systems, error rates are relatively independent of language, more highly correlated to the number of lines actually written. The language used is more or less irrelevant. I've found that I'm a better programmer when I'm sat in front of an iMac than when I'm hunched over a laptop. And I think I know why. This is a function that you probably can't see, at least at the back, that's doing a deep clone of objects with cyclical data structures. And there's a line here where it says, if is primitive thing, then return thing. Because if it's a number or a string or a Boolean, then you don't need to deep clone it. You can just return the same value. Now, the definition of that function is down here at the bottom of the screen, which means that as I'm reading that main function, I can glance down, look at the implementation, understand what it's doing, and go back to where I was and continue reading. If I'm on a laptop, on the other hand, I have to find the definition, scroll down, find the function, understand the implementation, keep it in my head, go back to where I was before, and continue reading. All of a sudden, comprehending what this code is doing is much more difficult. And it turns out a lot of the ways that we try and wrangle unwieldy code bases make the problem even worse. We'll add comments, or we'll refactor, we'll turn things into multiple functions, like this clone array and clone object function down here. All of these things have the effect of increasing the amount of code. It becomes a vicious circle. At some point, you'll probably decide that you want to put it into a separate module, and then you've got even more problems, because you can edit code without being aware of the various dependents of that code. And it starts to add organization and hierarchy and other things that extinguish any joy that you might have experienced once as a programmer. So write less is not just about decreasing the cost of experimentation. It's not just about preventing repetitive strain injury. Write less is about building better, more robust software. Now, you might think that this is all well and good. This sounds plausible, but actually there aren't many opportunities to write less code because the code is going to take as much as it's going to take. I'm not sure that's the case, though. If you look at most modern code bases, I think you will find a lot of code that does not tell. And I'm going to show you what I mean. So let's suppose that we wanted to implement this big red button. Perhaps it's going to release some confetti from the ceiling or something like that. And we could build it as a web component. Quick show of hands. Who's using web components in production? No, almost nobody. OK. So the way that we might do this is we'll first have some boilerplate. We extend HTML element and do some other stuff that you need to do because it's a class. And then we'll start to add our markup. We'll put a button inside the shadow DOM. And then we'll add some styles, also in the shadow DOM, which means that this stuff is encapsulated inside that component, won't leak out into the page. Also created an audio element and given it a source. Starting to break the one-screen rule, so we'll make this a little bit smaller. Then we need to get a reference to the button using query selector. And then we'll add some event listeners. When the button gets clicked, we play the audio element. When the audio plays, the button is disabled, so you can't click it twice. When it ends, the button is no longer disabled, and it pops back up off the screen. And this is fine. This works. But it's a little bit, when you look at the amount of code that isn't really expressing my intent as the component author, but is kind of just there to tell the browser what it needs to do, there's a lot of it. And the code that is expressing my intent is trapped inside this big blob of JavaScript string, so I don't get syntax highlighting or error checking or all of the other things that make development bearable. Now, this is a pretty simple component because this is a conference talk, but when you start adding more interactivity or have attributes and props, this gets really hairy really quickly, to the extent that I can't honestly recommend that you write web components. Feels good to say that out loud. I've actually written about the shortcomings of web components as I see them. I'm not going to continue on this topic for too much longer because I'll probably start to get heckled. But in the interest of fairness, I should say that there are libraries out there that will partially address some of those shortcomings. So if we're not going to use web components, then maybe we should use a framework. If we're going to use a framework, then we should probably use React, because React is the most popular framework, and it is excellent. So let's start. First, we have some boilerplate. Then we add our markup, the audio element, and the button. And this time around, we don't have a way of putting styles in our component because React doesn't really deal with styles. We could import a CSS and JS library, but that's like a whole thing. So let's just do some inline styles for now. It's not perfect. I can't edit these styles in DevTools and then copy the result back into my source code because all of this stuff is camel-cased and quoted and everything. So it's not ideal, but it's fine. We can work with it. We need some state representing whether or not the audio is currently paused so that we can use that for our button's disabled state. So we'll use the useState hook inside React. And we need to get a reference to the audio, so we'll use the useRef hook as well. And then we can add an event listener. When we click the button, the current value of that reference gets played. And we'll add some event handlers to the audio element as well that toggle that pause state using the setPaused return value from the hook. And this is undeniably much better than the web component version. It's still not ideal, though. In particular, I don't like the fact that before we even begin writing our markup, we're already at 3 levels of indentation. Time for a joke. So an Englishman was visiting Southwest Ireland and asked one of the locals for directions to Dublin. And the Irishman said, well, if I were you, I wouldn't start from here. Now, this resonates for me as a developer because a lot of times people will come to you and they'll say, we need to build X so that we can do Y. And a lot of the time our job is to think, well, actually, I could build X, I could give you directions to Dublin, but the best way to do Y is something completely different that you hadn't thought of. It's happened to me a lot in journalism. I'm sure it's happened to you in your respective fields. It also teaches us that if you've made what you thought was progress, it's OK to abandon that if it turns out that you're in the wrong place. So let's imagine someone came to you and said, we need to build a way of putting HTML and CSS inside JavaScript so that we can have declarative encapsulated components. Well, you might invent web components. You might invent JSX and CSS in JS. Or you might say, well, if I were you, I wouldn't start from here. I'm going to ask you a question, and I want you to shout out the answer. What is the language of the web? Most of you got that wrong. It's HTML. When you go to a URL, you get HTML. And the HTML can contain JavaScript. It can contain CSS as well. But HTML is the mother language. So given that, if we're describing user interface components, then wouldn't it make sense to use HTML as our starting point instead of JavaScript? So let's do that. We'll add an audio element and a button right there at the root of our component. And since we're inventing this, we can stipulate the styles inside our style tag, and we can just use regular CSS. They'll be scoped to the component so that it doesn't leak out into the page. We'll need some state representing whether or not the audio is paused, so I'll add that script at the top, let paused equals true. And we could use event listeners to toggle that state. And again, because we're inventing this, we don't need to use any kind of component API like setPaused. We can just do paused equals false or paused equals true. Bit more natural. But actually, earlier when I was saying that the surface area for bugs increases with the number of instructions, this is the kind of thing that I'm talking about. These are instructions. It would be better, really, if we could just say we need to bind the value of paused to the value of whether the audio is paused. So let's do that instead. And we could use the same thing to get a reference to the element. And then we can add our event handler that makes the audio play. So the punchline, of course, is that this isn't an idle thought experiment. This is a Svelte component. Svelte is a framework that I started building in 2016, and it's different from most component frameworks in that it is, in fact, a compiler. What it does is it takes your declarative component code and turns it into various forms of output. It will give you a module that generates server-rendered HTML. It will generate static CSS that's scoped to the components. In other words, it gives you most of the benefits of CSS and JS, but with none of the drawbacks. It'll give you a client-side module that you can use to create an interactive application in the browser. We have bridges to native script so that you can target iOS and Android. And we can even generate web components. And you can see the result of taking that approach when you put these side by side. The React version of that component is 46% larger than the Svelte version. And that's about typical. I found like I've converted a lot of components between the two frameworks. And it's usually about 30 to 40%. So if our hypothesis about code size increasing bug surface area is true, then it stands to reason that you will get a more maintainable code base if you have the minimal Svelte implementation. Notice that I'm using characters instead of lines of code here. I think it's a better metric for code size. For one thing, it's more tightly related to the screen real estate required by this code. But also, it encourages punchier code, right? In the same way that when you're speaking, if you use short, snappy words, you will be better understood than if you circumlocute grandiloquently using all kind of loquacious and sesquipedalian pleonasms. When you're writing code, the shorter you keep it, the better the understanding will be. Now, the reason that this is possible is the reason that this works is because we're following the contours of the web. The web is built from HTML, CSS, and JavaScript working side by side. Those three languages form the platform. So I want to say to those of you writing HTML and CSS inside JavaScript, inside your web components, come on over and use the platform. Now, when I started building Svelte, I thought that the main benefit of compiler-centric design was that we could get rid of the bloated framework runtimes and ship smaller applications that would start faster. And that's true, but I no longer think that's the main benefit. And then, more recently, I gave a talk earlier this year called Rethinking Reactivity, in which I argued that the main benefit was that a compiler can generate applications that are much faster, so you can do more stuff. But I no longer think that's the main benefit either. I've come to the view that the main benefit of compiler-centric design is it gives you a larger solution space. And what I mean by a solution space is the set of all possible design decisions that satisfy the constraints that you're working under. So here's React solution space. Somewhere in here is JSX and Virtual DOM. And here is Preact solution space, which is very largely the same, but they have this additional constraint that the library can only be 3 kilobytes in size. And then we have Vue solution space, which overlaps React to a large degree, but also has some extra stuff on the side. Now, when we abandon the constraint that the code that you write is the code that runs, in favor of thinking about code as instructions to a compiler, your solution space gets much larger. It's not free. There are trade-offs. You do introduce new constraints. But what we've found is that this gives us a much better set of trade-offs and gives us a lot more freedom in how we design these things. And we're using that freedom to pursue the legacy that jQuery left us. Write less, do more. Part 2, do more. The reason that I loved jQuery so much all those years ago, it wasn't just that I could do the same amount of stuff with less code. It was that I could do more stuff. jQuery was like a mech suit around my puny human body. I could do Ajax and element transitions and all of these other things that, frankly, were beyond my skill as a programmer at the time. And the best thing of all is it was all built in. I didn't have to go hunting for these bits of code. It was right there in the library. Nowadays, we don't really develop like that. Nowadays, we have NPM, which means that building an application is largely a process of assembling applications from different pieces that aren't necessarily designed to work together. Right? You all remember that episode of MacGyver where he has to build a to-do list? Right? That's kind of our lives, right? Our expectations have dwindled. We used to think that we used to advertise tools on the basis that you would be able to do so much if you used them, but now we advertise tools using words like lean and minimal and simple. And we on the Svelte team kind of reject that dichotomy. It comes from a good place. It comes from a recognition that we're shipping too much JavaScript, but the result can be so chaotic that I don't think it results in a benefit to the user at the end of the day. So we asked ourselves, why not both? And so I'm going to talk about some of the ways that Svelte tries to decouple feature set from file size. First off, because we're a compiler, it doesn't really matter what size the package gets to, as long as the compiled code is small. So we can start adding features that you would never dream of adding to a normal framework. For example, we can do compile time accessibility checking. I'm redesigning the JScamp website for next year, and it's giving me some accessibility warnings at the moment. You can see them at the bottom here. This first one is telling me that the image element should have an alt attribute. This is important because if someone's using a screen reader, or if they're on a slow device and with bad connectivity and they haven't managed to download the image yet, it's important that we can help them understand what this image actually contains. So I add an alt tag, and that warning goes away. It's also saying that the anchor element should have an href attribute. And yep, I've done this window.location.href equals thing, which you sometimes see. People using anchor tags as buttons instead of links, and that's no good. So let's just fix that real quick, and that warning's gone away. And then it's telling us that the fig caption should be a direct child of figure, and that we shouldn't have this marquee element. I'm not sure I agree with that, but the accessibility experts tell us that it's difficult to click a moving target, and it also causes a bit of a distraction. So let's just kill two birds with one stone, get rid of that. And we now have an accessible JScamp 2020 website. Another thing that we make good use of is tree shaking. So this is an app I'm building where David's disembodied head follows the mouse around the screen. If I click, then he'll grow larger. And it's all Spring physics, so I can do this sort of thing, which is important to me for some reason. And it comes from the Svelte motion package. And if I were to not import that function, or if I were to import something else from Svelte motion, then that code just wouldn't get included in our bundle. So we get all the benefits of having the feature, but without the cost of having to pay for it if we're not using it. Tree shaking, by the way, if you're not familiar, it's a feature that exists in modern bundlers that basically just gets rid of all of the code that you're not using from the modules in your dependency graph. And then finally, a companion piece to that, we selectively import things as we need them. So this is a dynamic chart that re-renders as the element resizes. And it does that using these width and height bindings here. Now, if I were to get rid of those, then this add resize listener function that gets imported by the compiler would just disappear as well, which would mean that it would no longer get included in our bundle. Similarly, this element helper, which is just a wrapper around document.createElement that's a bit more minifiable, it's used to create the elements that stay on the page. In the area chart, we're using SVG elements, and you can't use document.createElement to create SVG elements. You have to use document.createElement NS, which stands for namespace. So we have a separate helper, SVG element, which creates things like this group element. If your application doesn't contain any SVG elements, you don't have to import that helper. And that pattern repeats itself throughout the framework, so you only ever include the things that you're actually using. We're trying to apply the same mindset to other problems as well. This is a component library that allows us to build three-dimensional scene graphs inside Svelte. It's called SvelteGL, and it looks a little bit like this. We have a top-level scene component, and then inside there, we've got various objects like a plane and a box. And because it's just a Svelte document, we can mix and match it with DOM, and we can use the same reactivity system. So we can do things like this, change the color a bit, spin it around, zoom in and out, and it's kind of fun. This isn't really ready for prime time. We've used it at the New York Times for a couple of pieces, but it's not generally useful yet, but hopefully it will be soon. And then finally, we have a full-stack framework called Sapper, which is a companion project, very similar to Next, Nuxt, and Gatsby. But again, it tries to look at your code base and understand the ways in which it can generate an optimal user experience from the code that you've written. Part 3, but also do less. So here are some ways that we try and speed up code. We put everything in a web worker, except that doesn't really work because it adds complexity, there's serialization costs, and so on. It works for some things, but not everything. Breaking work up into chunks using request idle callback or time slicing or things like that. It can certainly improve perceived performance, but it's not going to improve actual performance, and if used incorrectly, it can make your application more sluggish. It's not a panacea. Rewrite everything in Rust. Quite fashionable these days. As Vladimir shows us, that's not actually going to help in most situations. There are some tasks to which it's very well suited, but it's not a general purpose solution. There's only one thing that reliably makes your applications faster, and Vladimir already went into far more detail than I can on this, and that is just do less work. And this is kind of what Svelte is trying to do. Because it's a compiler, it can statically analyze your code, determine the various possible states that it could be in, and when a state change happens in your application, it will do the minimum amount of work possible to bring it up to speed. And the reason that this matters is that the mobile web is no longer the new frontier. The new frontier is the embedded web. Smart TVs, smart home control panels, wearables. A lot of these devices have screens. A lot of them run apps that are built with web technologies, some of them built using Svelte. And you really don't have a lot of wiggle room for performance. A lot of us are probably going to be writing stuff for the Internet of Things in the next few years. It was recently suggested to me, though, that there might be a more important reason to think about doing less work. Planet Earth is in a bit of a pickle. The ice caps are melting, the seas are rising, the insects are dying. It's putting stress on food security, water security. It's exacerbating refugee crises around the world. Meanwhile, the people who are running the show are either in denial about it or they're trying to figure out how to profit from it. Meanwhile, as individuals, we can only do so much. Your decision not to eat steak is not going to avert the apocalypse. But as technologists, we have a unique opportunity because we can kind of make decisions on behalf of all of our users at once. And I think we need to start talking a bit more at conferences like these about what our responsibilities are to the environment. I want to shout out to Andre Stoltz and Asim Hussain, who have bucked the trend by doing talks on the environment and technology recently. From Asim's talk, I learned that data centers have a worse carbon footprint than the airline industry. That comes from a study that came out 4 years ago. Data center usage has doubled since then. I don't think airline usage has doubled. So, in other words, the physical internet is a very real part of the global climate emergency, and by extension, so are we. And so perhaps we need to start thinking about the ways in which we could mitigate some of that effect. For example, if you have a server-side rendering solution that uses drastically less CPU, then you could scale down your back-end infrastructure. Some of the other ideas that might make sense. Loading code lazily. This was Sean's whole deal, right? You load code as and when the user needs it. A lot of us are already doing route-based code splitting or route-based code splitting if you're an American. But we could be doing feature-based code splitting as well. And Sean alluded to this. And this, by the way, I think is the progressive enhancement ideal, right? A user can select increased fidelity when they're using an application just by interacting with it naturally. And we have the technology to do this. We could track our users less. I might get in trouble for saying this given where I work, but Google Analytics has an environmental cost, right? It takes energy to collect that data, transmit it over the network, and store it. At the New York Times, we have a scroll event listener which communicates with our ad tech partners that tells them whether an ad has been viewed. I don't know what the environmental cost of that is, but it's not zero. So perhaps we need to be starting to think about whether or not our business models around this stuff make sense. Finally, better tooling would go a long way. The next version of Safari is going to have this CPU timeline, which will tell you the energy impact of a page while you're using it. This is a really good start. I don't think it goes far enough, but it's a brilliant start, and I hope that other browsers follow suit as well. And I'm sure there are all sorts of other things that I haven't thought about. So if you have ideas about this stuff, then talk to me. I would love to hear them. So hopefully I've convinced you that writing less code and doing more is better than writing lots and doing little. It follows logically, therefore, that the best answer would be to write nothing and do everything. And I'm only being a little bit flippant because we used to have this, right? This used to be a thing. People could be creative on the web using visual tools that they could bring their whole creative selves to. And that's no longer the case. I'm not the only person who remembers this, right? Okay. We kind of lost that. When Flash died, a lot of that creativity died with it. And we haven't really been able to recover it. And I think we can reclaim that lost ground if we're careful about it and think deeply about the right building blocks. And I also think that it's really important, because the best thing about jQuery was its inclusivity. jQuery said to people like me with no discernible programming skill, you too could be a part of this thing. But we haven't gone far enough. There are still a lot of people who are excluded from bringing their creativity to the web because they're not skilled at blindly manipulating symbols like we are. So this is where I hope that this work goes. I want to enable more people to be able to bring themselves to the web and be part of this whole thing. And if that's a future that appeals to you, then I invite you to come and help us build it. It's going to take us a little while, but I think we can get there. Thank you.